Okay, so yeah, so many people here. First of all, I'd like to thank DevOps Greece, the whole team for inviting me to speak again here in Greece. I was last year in Thessaloniki. It was really great. Had fun presenting something about GraphQL, but now I'll be presenting something about microservices and making it fault tolerant. So, just a quick introduction about myself. So, I'm again Devlin Duldulao. I'm a Microsoft MVP, originally from Philippines, Manila, but now living in Oslo, Norway. I've been living there for 4 years now. And I've written a couple of books, Spring Boot with Angular, ASP.NET Core with VJS, and Practical Enterprise React TypeScript. So, yeah, so again, this is fault handling with retry and circuit breaker design patterns. Agenda would be exposing microservices. That's first. We'll see what is microservices first, and how will you expose your services in outside world. Second would be retry policy. Third will be a circuit breaker pattern. And we have, of course, the demo of retry policy and circuit breaker pattern in Spring Boot 3. This is not 2. 3. It will be 3. So let's start. So how can retry policy help us improve the end user experience? Well, here's an application. Let's try I have something here. This is my first time to use this. Okay, so yeah, that's the app. Okay, and we have our user here on the other side. So I'm not gonna use my that one again, my toolset. But anyway, this isn't using retry policy yet. So for example, so we start off here with our user making some requests, right? Using the application. Then the application here needs to go off to some external service, right? And this could be a temporary problem that you will encounter here. As you can see, it's like this no entry in the remote server, that the network connectivity dropping out for just a moment. It happens. In any of these cases, we're going to have result in some error conditions in the application, and then we are going to tell the user about this error condition. Just like, for example, in UI, you have this flag or info, right? Something happened, and then we're going to tell, yeah, and then we perhaps might say something like, please click again, or please try this again later. So yeah, why web service requests fail? So let's find out. Your web service request travels over a combination of cross unreliable communications channels, traversing more computers, right? Causing even more complex and unreliable software to execute. Examples would be infrastructure upgrade, faulty network connection, null reference on someone else's code, server unavailable, bad deployment. It happens, and it could be more cases. So a retry policy can retry a failed request with just a few lines of code, but that's only the start of what a retry policy can do, which will I explain later. Now back to the failing request, right? This is the app that it's failing. So rather than the user having to go and click button repeatedly, like just imagine this is the mobile app, clicking, right? And until it eventually succeeds, we can get the retry policy to do this for us or for the user. So rather than immediately returning returning an error message to the user, the retry policy will automatically go and retry the request again. And a retry policy can be configured to go and retry, for example, third times, fourth time, or fifth time. It's up to you. So this time, let's say, imagine the operation succeeds, and we can return the result to the end user. So now it succeeded. This all happens transparently within the application. So the user this time has not received an error message, and they also haven't had to go and manually click the retry, not the retry button, but the sending button or submit button from the form multiple times, right? So this talk is for microservices and not for the front-end applications. And it's going to be like about downstream microservice failure, aka dependency failure. But first, let's talk about what is microservices for newers. Microservices are usually built to be called by applications or used by external consumers. So the way it's done will determine how the software should be developed and how it can evolve. There are 3 ways to expose your microservices. The first method is to expose all microservices directly. Just don't do it. I'm not gonna explain more about this. We don't have much time. The second one is to build a special microservices called facades, representing an entry point into your system. And the third method, or the third way, is to use external software called API gateways, which will provide those external entry points. So let's go to the first one. First option is to expose all microservices directly. Just don't do it, right? So let's move to the other one. It's bad, you know. You'll see why. Let's go to the bad side. Multiple entry points, internal architectures directly exposed to the world. Evolution is difficult to or impossible, and there's no clear parameter. So just don't do this. Let's move to the next one. So did you see this? Okay. So yeah. The next one, which is very important, is to expose your microservices through specially developed facades. There are 3 different ways how you can do this. First is to use this first subtype would be to have a single facade that exposes the system full functionality. So this method will allow you to protect your internal designs and make the evolution of the microservices a lot easier. You know, you will have only a single entry point into your system, which will make it easier for consumers to use your system. So the facade will give you a place where you can introduce additional logic, where you can provide some sort of caching or call multiple microservices, compose their results and return as a single object. So this is where you massage the responses from different services, right? So what else I can say here? You can use consistent development practices here for your internal microservices and for your facades. You can build them. You can version them, right? And you can release them. Oops. Yeah, you can release them and you can deploy them into production using the same set of processes and automated templates. So yeah, there's some pros here. Single entry point, which I mentioned already, rich multi-protocol, async notifications, and more. What are the cons? Cons. Drawback of that approach is that you need to do extra work to implement those microservices. And if you need to introduce a new feature into your system, most likely it will affect your facade. So facades will be constantly updated. So that's the first subtype here. Second would be, probably if you've been also tried this before, the second variation of facades is the so-called back-end for front-end or back-end to front-end facade. It looks like this. So this facade is built for specific consumer. Usually an application is optimized for calls or requests from the front end. So it has similar approach to the first option. You can protect your internal design and make future changes a lot easier. You will have only single entry point for a specific application. Probably you've tried this before, so imagine the app one is a React Native or an Ionic or an Android or an iOS, and the app two would be a web client, like an Angular or React, right? And they've been separated because the mobile app UI is different, the functionality could be the same, but the request it's sending is sometimes it could be different. So the response from the API should be different, and that's why you're separating them into its own facade, right? So in short, BFF. And so yeah, cons here would be is additional work again for you to implement. Another facade here would be our third option for the facades is implementing multiple facades. So each facade can expose logically well-defined set of features for your consumers. Similar to single universal facades, they will protect your internal architecture. You can use consistent development practices, and this can also be platform agnostic. So here are the pros, as you can see. Let's go to the cons. Multiple entry points, higher complexity, and then you have this extra work to implement. But it's still good. This is what we've been doing in our projects. We have this facade, entry point, and then we're just calling different services, different Spring Boot services, and also different .NET services. So third option here would be the API gateway. So there are different options you can have here. So there are cloud-specific implementations of API gateways available on Microsoft Azure or AWS Cloud. You can have free and simple solutions using Kong and Nginx Plus. Complex and feature-rich API management platforms will provide external interfaces and create website documentation. That's good. Client SDKs and more. So this is most of the time managed, right? And I'm going to give you an example of how it would look like if you haven't tried this. So in Azure, you have this admin or this dashboard, and there's so many options here that you can use. And exposing your endpoints would be just like click and click, right? This is totally different from facade, because in facade, you'll be writing controllers and routers. But in API gateway, since it's managed, you can just here get right, and these are the endpoints. And what's good about this is if you have an existing Swagger UI or Swagger endpoint with JSON, it returns JSON, right? You can just copy the endpoint of your Swagger and then drop it here in this API gateway in cloud, and then it will automatically map all your endpoints. It will just automatically create it for you. So you don't have to do anything. I just mentioned earlier, you can just click, and then add manually, but you don't have to do that if you already have an available Swagger UI, right? It's just good. And what else is good in managed API gateway? There's so many protection layers you can add here. You have this inbound processing. Click if you want it, right? You don't have to code anything. Just click. Configuration, of course, you need to that. That would come later. And for example, in inbound policy, you have this filter IP addresses, limit call rate, mock responses, validate content, cache responses, other policies, set headers. So again, this is difference between facade where you'll be doing this manually versus a managed service in the cloud. So there are several pros to using API gateways. So similar to facades, they will protect your internal design and make the evolution of your system a lot easier. You will have single entry also into your system, and API gateways are very good at providing, those cross-cutting concerns like security, logging, throttling, tracing, and others, right? So let's move quickly. Cons, extra technology to learn and maintain. Of course, you'll be studying or learning a new technology. For example, in AWS, their own API gateway, or in Google Cloud platform, or in Azure, Microsoft Azure. And yeah, what else? Limited functionality. This is usually in the very beginning of, for example, a startup API gateway, a limited functionality, hard to support complex processing. Have this also multi-protocol or async notifications, and inconsistent development and delivery practices, mostly in an API gateway that just started. So, but of course, if you'll be using Azure or AWS or Google Cloud, most of the time they're already stable and fully mature. So we have to go back. So that's exposing your microservices. Really quick overview. Now we have to go back to the main topic, which is fault handling. Yes, retry policy. So retry policies are nothing but, you keep retrying. That's it. So you make a request to another service, or maybe an external API or service to get data, then you can choose what kind of approach for waiting time. You have here constant, exponentially increasing, which it multiplies. The more failing requests, the longer it would send the request, the longer interval it will have in the next request. Specified list. Yeah, that's for the retry policy. For the circuit breaker policy, this is especially important when you're sending lots of concurrent requests. You can quickly run into big problems such as port exhaustion. If you're using HTTP client, that may seem like, if you don't have this circuit breaker pattern or policy. So I'd like you to remember, whenever you're implementing retry policy, you need to have this circuit breaker policy. They go together. And without this, it's like you're DDoSing your own services, your own project, your own application. So you're shooting yourself in your foot. So that's what's going to happen if you don't have this circuit breaker, that one, but you have retry policy. So they go together, always. Another concept that I'd like you to know is this electrical concept, which is in circuit breaker pattern. When the circuit is closed in electrical circuits, when the breaker is closed, indicates that electric current is passing, right? So if it's closed like this, the flow of the electricity is passing. So in the resilience pattern, it means that you're passing requests. So that's for the close. I'd like you to remember. And if it's open, so imagine these are the wires. So if it's open, as you can see, it's like a bridge that the bridge is open. So the circuit does not pass the request to the destination, only returns to the requester that the service is out, avoiding to overload the destination with new requests. So it's not passing, it's not accepting any requests. So that's that. And these are state, by the way, of circuit breaker. And we have here close and open. The third state will be half open. So in half open, we're just testing the waters. So if the circuit breaker state is in open, in half open, so it will just allow one request. If the request went through, okay, it will just fully close it, meaning everything's all right. But in half open, if this one request we're allowing it and then it failed, it will still keep on, opening it. So meaning it's still, the server is still out, is still down. Or imagine the AWS data center is still down for 6 hours. It happens, right, in data centers. Yeah, so that's a explanation for this half-open state. Now, we also have a term called infrastructure-based resiliency. So to implement infrastructure-based resiliency, you can use a service mesh. So a management interface, which could be a UI or an API. For example, Istio. With Istio, you can define retry policies, traffic rule. So those are the cases. So now, this sample of cloud infrastructure resiliency. Let's move back to this configuration here that you can see, this XML configuration policies. This is from Microsoft Azure. So if you have other very specific configuration in policies, you can put it here. So for example, here inbound. So we can add this retry conditions. So you have to make sure which condition. You don't want to retry a failing authentication, right? It's like, okay, maybe your password is correct next time. Maybe your so you don't do that. Normally, you only do this in 503.404. That's an example, not in authentication failure. Count. You also have count, interval, first pass retry. So these are just an example in a managed service. So these are example of cloud resiliency. Now going to code-based resiliency, that's where you're here. We're gonna implement this. To implement code-based resiliency, you can write a logic or use your own, or use a third-party library for resiliency and transient failure handling. In Java, this is what I'm using, Resilience 4J, right? And where can you apply this Resilience 4J? So Resilience 4J, for example, where's my mouse? Or where's this? So yeah, so you have this API gateway, right? And you have a facade. So this is a combination of facade and API gateway. So you have this facade one and another facade here. So the retry policy will just, coming from here and here, as you can see. Facade, you'll be writing it on your own. So meaning your retry policy will also be manually coded in your facade, or just use a library. So now said, let's go to demo. Let's end this slideshow. Oh, that's good. It's already there. Let's make this bigger so we have more code to see. So I have two services here. One is facade and one is, let's say, a to-do service. And I also have a Swagger here, so we don't need to create an application, a front-end application like a React or Angular. We don't need that. We only need this. Swagger. Just imagine this is a submit form. What else? We have this actuator here, endpoint. And this is for showing you the state of the circuit breaker. It says here open. Let's delete this. That was my when I'm trying out later. But by default, of course, it should be closed. Otherwise, open will not accept any request. So I guess it's already running. Facade, yeah. Let's double check the other one, the to-do service. It's already running also. So this service is just returning a random number here, as you can see. And this dynamic ID will come from a URL path. And what's going to happen is we have here random from between 1 to 100. If the random number is greater than the ID, let's just throw an error, 500 error. If, of course, if the random number is less than the ID, we'll just return service. So, if 50-50 chance, if I just send 1, 2, 3, most likely it will fail. If I send 98, 97, 99 ID will just pass. Okay? So that's the idea here in this to-do service. For the facade, okay, so for the facade, let's go to how you will configure that library. So is this here? So yeah, application YAML management. This is what you need. So these are coming from the documentation. I didn't write this. You can just go to the documentation and grab it and then start editing it. Circuit breakers enable true, yeah. Endpoints. Health, so resilience 4J retry, here it is. Instances, you need that. I'm going to show you later what is this. Instances, registering facade, and name, you can name this whatever you want, but I'm going to name it facade since I'm in this facade service. Wait duration, 2 seconds. Max attempts, 4 before it fails. So the first 3 attempts of failing, it will not register fail until the 4. So max attempts 4. So you can enable also the exponential back off, which a multiplier here with 2. And what else? For the circuit breaker configuration instances, I'm gonna name it again facade because the circuit breaker must live in facade. Minimum number of calls, 8. Wait duration in open state, 60 seconds. So the service will just wait for 60 seconds before it can accept requests again. Yeah, nothing more special here. Let's go here to the controller of this facade. I'm gonna name it to-do facade because it's sending to the to-do service. I think it's already running. I'm gonna explain this later, but I think it's time now to just show you what it does. It's too big. Yeah, that's okay. Double check. So everything is, maybe we can just, yeah, disable this first so you can see. Okay, it's running now. So this is gonna fail, 99%. So execute. So you can see 500, 500, 500, 500. So without retry policy, without circuit breaker, this is gonna happen, right? The user will just keep on clicking. It's like flooding your server, but it can't help because the user is doing something that he needs to finish. That's why you keep on pressing the submit button until he quits and then just leave the website. Move to another one, your competitor. Now let's enable first. I guess let's enable first the circuit breaker because it's easier to understand. So running it again. So this is the instance, right? I put there in the configuration that, yes, that this facade is the name of the service. So we have that. And let's go back to that failing request. Execute. It says here, call not permitted. circuit breaker facade is open. Refresh this. It's open. So if it's open, we can go back here. Wow. You can see that the difference between rate limiting and circuit breaker is that in rate limiting, it protects the target server. So this is the target server, this to do here, right? That's the protected server in rate limiting. But in circuit breaker, let's just send this, send. You can see that I have a breakpoint, but it's not getting into the service, meaning the circuit breaker is just in the one who's sending requests. It protects the one that's sending requests, the client side. Because the service, even though it's a service, it's using HTTP client, it's a client. I guess the 60 seconds will already pass. That would, create a breakpoint there. That's right. See? So meaning it's already closed. It starts to accept requests. Oops. Just move. Let's refresh this. It's not yet done. Oh yeah, it's failing because, again, we have one, but let's do 99 here. Oh, I guess I did it too much. But anyways, so that's the idea. Circuit breaker protects the one that's sending requests. Rate limiting protects the target server. So let's enable now the retry policy. And just to show you that it's going to send retries, I guess let's use around 35. Oops, let's remove that breakpoint. As you can see here, it's sending requests automatically until it fails for the fourth time. Or I mean, for sending requests, and then you have fifth time. Let's do it again. Let's now increase it to 40. Hope it's accepting now. $200. 200. It passes right away. Let's go back to 35. Yes, there you go. So this is gonna be what's happening in the front end, loading, because in the back end, it's sending it every 2 seconds, right? And then until you open it again. So this is a wonderful part of having a fault tolerant in your microservices, retry policy, and circuit breaker. So because it automatically send requests to the target server without letting the user click the button. So yeah, these are just annotations you can use, very easy to use, with really good developer experience. Retry policy, circuit breaker, and then the set of this configuration is just in this YAML resources. So one more before we see loading. And then you can see that it's still sending. Okay, so that's for the demo. Let's use this separate again. And let's move back to the slides because I have only a few minutes. So other usage scenarios of retry policy, reading, writing to file system, using databases, reading, writing to message queue. Summary, retry policy, the request is retried after short wait if an error response is received. Circuit breaker policy, gives the target service a break after a repeated number of failures. So again, this is totally different from rate limiting, because in rate limiting, it only protects the target server, where circuit breaker, it's in the client, service, which the one who sends request, not letting the request fly to the target servers, just stays there. What else? Yeah, I just mentioned that. Again, there are two fundamental approaches to resiliency: infrastructure and code. The code is the one that I just demo. The infrastructure is which is available in an API gateway. So if you're gonna ask me which one to use, API gateway, because you don't have to do a lot of things. And API gateway, normally the number one consideration why you would choose API gateway is security. Why? Security is hard to make right. The demo code is here. Resilience for the demo from my GitHub, and the GitHub, yeah, the demo. So yeah, that's the same. So, but anyway, I hope you learned something today. Yeah. So if Haristo.